Today's daily LeetCode problem of the day is sort the jumbled numbers number 2191. For this problem, we're given a zero-index integer array mapping, which represents the mapping rule of a shuffled decimal system. So in this scenario, mapping of I is equal to j means that the I should be mapped to the digit j in the system. So if we look down here, mapping is equal to an array of integers, and it's going to go from index 0 to index 9. If we have a 9 here, we're going to look at the 9th index in this array and replace that number. I say replace, but we're mapping it. We don't want to replace it because we want to return the original numbers themselves. So the map value of an integer is the new integer obtained by replacing each occurrence of the digit I, or each digit in a number, with mapping of I. So 9, we look at index 9. 1, we look at index 1. We're also given another integer array, nums, and we want to return the array nums sorted in non-decreasing order based on the mapped values of its element. So, in this case, this would turn into 669, this would turn into 7, and this would also turn into 7. However, we're going to put 338 first because it comes first in our original array, then 38, then 669 because that's the mapped value. So we're sorting in mapped value. So elements with the same map value should appear in the same relative order as in the input. So 338, because 3 is equal to 0, 8 is equal to 7. These are both equal to just 7. We're going to sort them in the original appearance order. The elements of nums should only be sorted based off their map values, not be replaced by them. So we want to return our original nums array. How do we do this? First thing we're going to do is we're going to make an object pairs that will store mapped value with original value. So this object pairs is going to take an input that is going to be the mapped value of a number as well as the original value of the number, where they're going to sort these objects based off of their mapped values, and then we can return the original values in whatever order they end up in. So how exactly do we do that? First things first is we're going to want to create an array list with our mapped values. Then we're going to create an array list with pairs containing mapped values and OG values. Then use a comparator to sort by the mapped values in pairs. Turn our pairs.ogvals into an integer array and return that array. This seems complicated. However, this whole solution will take O of n log n time, so it is pretty efficient. Let's first initiate our object pairs. So class pairs, and it's going to receive two values. First value is an integer ogval. Second is integer map val. Then when we're creating this object, we're going to have a public pair. Yeah, let's name it pair, so it's, actually we can call it pairs. Public pairs. It's going to receive two values. It's going to receive an integer ogval and an integer map val. Then we can do this dot ogval is equal to ogval, and this dot map val is equal to map val. This just makes sure that this, as in this value, is equal to whatever the input value is. So now let's create our array list with our map values. So first things first is define the list. So list, it's going to be a list of integers. we could call it mapped vals is equal to a new array list. Boom. Now we're going to do a for loop. So we're going to loop over nums and calculate the mapped values for each number in nums. So for integer I is equal to 0 as long as I is less than nums.length I plus plus. So we're going to need a couple things as we iterate through nums to calculate the values. As we can see, these values can be multiple digits long. So how do we account for that? We can use a multiplier. So if we use %10, we will get the first digit. Then we can do divided by 10 to get rid of that digit, and then we'll just have 99 left over. Then we do %10, and then we get 9. However, if we're going to add this to whatever our mapped value is, we're going to want to multiply it by 10 so it doesn't combine with 1. So we're going to initiate a variable called multiple. So int mult is equal to 1. That is going to be our multiplier. Then we're going to also initiate a temporary variable to store our nums of I in. That way we don't lose the value while getting rid of numbers and adding numbers to our map values. So integer temp can be equal to nums of I. So this is going to be our multiplier. It's going to reset to 1 after we come back and look at a new integer. This is our temp value that is going to store our nums of I so we don't lose it in the process. And so how are we going to transform it into a mapped value? Well, we are going to use a while loop. So while true, we're going to do a couple things. First thing is we're going to identify the number we are going to be mapping. So integer num is going to be equal to mapping of nums of I %10. So what does this do? We are plugging in a number into mapping. Mapping is our integer array with the values we are using to replace the other values. Nums of I is the current value we are looking at, and we're using %10 so we can look at whatever the first value is in that number. So now that we have the num that we're looking at, because we're using an array list, we want to make sure either we're looking at a new index or if we're looking at an existing index, we can add it properly to that index. So if I is greater than or equal to 0 and I is less than our mapped vals.size, then we'll continue on and we are going to add it to the current index of the array list. So this basically just checks if the current ith index of an array list exists. So if it does exist, we can do mapped. Sorry, my truck was open. Anyways, so because we're using an array list, we're going to do mapped vals dot set, and it's going to be the ith position. And what are we going to set it? We are going to set it as num. That is the value we previously identified, times our multiplier. So our multiplier is going to be 1, 10, 100, 1,000, depending on what position the number is in the nums array. That way it will fit in back into its correct position. And after that, we are then going to add mapped vals.get whatever was previously at the ith position. Otherwise, if the ith position in the array list doesn't currently exist, we're going to have to add it. So we're going to do mapped.add num. As simple as that. We're then going to get rid of whatever number we were currently looking at. So if we were looking at 1, we want to divide it and equal it by 10. And that gets rid of whatever number is in the 1's place. Then we're going to increase our multiplier. So mult is going to times equal by 10. And then we're going to identify whether or not we're going to continue with this while loop. So in what case do we not continue with this while loop? We will not continue with this while loop if the number we're looking at is equal to 0. Because if it's equal to 0, we're not adding anything unless the value is a 0 itself. In that case, it will go through this process, get replaced with whatever is at the 0 index. And if it's equal to 0 at the end, we want to break this loop. So if nums of I is equal to 0, we are going to reset nums of I back to its original value, which is temp, and break the loop. Otherwise, we are going to continue to do this while loop, mapping the number into the map of vals array list until the value is equal to 0. It'll only equal to 0 when we divide equal by 10, and there is not a number to replace that value. It'll just default it to 0. Cool. So this will fill our mapped values array list. Now, we're going to create an array list with our pairs. So how do we do this? So list pairs. We'll call it a pair object. Pair object, so we could call our array list pairs. And that's going to be equal to a new array list. How do we fill this array list? Same thing, similar, except we don't have to map the values. So for each integer I is equal to 0 as long as I is less than nums.length I++, we are going to add a new pair. So pairs.add a new pair. And what are we passing? So if we look up here, the first value is going to be the original value. The second value is going to be the mapped value. So first value is nums of I, and the mapped value is going to be mapped vals.get I. And so that creates our array list of pairs. Now we're going to use comparator to sort this by our mapped values. So we're going to do collections.sort pairs, and the comparator we're going to use is we're going to compare integers. So comparing int for each pair, we're going to do pair dot our, what do we call it? Map val. So what does this do? This is a sorting method for array lists. So we pass the array list that we want to sort. And then because it's not just a normal integer, it's not just a normal string, it's not a normal object, it is a custom object, we need to tell the collections how to sort it. And how do we sort it? We use a comparator. What are we comparing? We're comparing integers. Because there are two different integers in this value pair, which integer are we using? So for each pair in pairs, we are going to use the pair.mapVal. So we're going to sort it based off of pair.mapVal. After all, that's what we want to do. We want to sort the nums by their mapped vals. Now, we want to turn this back into an int array, because that's what we are returning, an int array. So, int, and we could call it out, is equal to a new int array of nums.length. For int I is equal to 0 as long as I is less than nums.length I++. And what are we adding to out? So out of I is going to be equal to pairs.get I dot OG val, our OG value. Then we can simply return out. So if we run this, passes our test cases, and if we submit it, passes all solutions. And it passes it in O of n log n time. Now let's do this in Python. So for this problem in Python, we're going to do something very similar, but we're going to use the lambda function because I didn't explain it very well last time I used it. The lambda function is basically a small function that you're defining and using right away. It's not something that is worth defining like a whole new function for, because you're only going to be using it that one time. So we can use the lambda function to define what we are going to sort with. So let's see how we can use that. First things first is we are going to define our mapped values. So mapped is going to be equal to an array of zeros, the length of nums Then we can do a for I in range length of nums. So for each value in nums, for each index in nums, we're going to have our temp is equal to nums of I, our molt is equal to 1, and then while true, it's basically the exact same. Our num is going to be equal to mapping of nums of I %10. Because we're not using an array list, we don't have to determine if it's existing already. Because of this, we already determined that all positions are existing. So what we could do is mapped of I plus equals our num times our multiplier. Simple as that. Then I want to do this actually instead. So we're going to use temp %10. So that way we could save space on returning nums to back into its original form. So instead we're going to do temp divided, remember to use 2 slashes, by 10, and molt times equals 10. If temp is equal to 0, if temp is equal to 0, we're just going to break. As simple as that. Now this is how we are going to sort it. So like for Java, we turned each of these values into pairs. So we had a nums original value and a mapped value. We're going to do something similar. So we're going to do a combined list, and that is going to be equal to, what we're going to do is zip together our nums list and our mapped list. So now that we have combined, we want to sort it. First, we need to make sure that we make this a list. So list zip nums and mapped. Now we're going to sort it. So we're going to do combined sort. It's going to be equal to sorted. And we are sorting our combined, and we're sorting it using a key. So our key is what we are going to be sorting based off of. Key is equal to a lambda function. Again, this is a small function that doesn't need to be defined on its own, but we are using just this once. So lambda, and that's going to be x. So for each value of combined, we are going to be sorting. So let's say x is the combined of 0. So which value of that are we going to be using? Because combined of 0 is nums, combined of 0 is nums, combined of 0 of 1 is mapped. We want to sort by mapped. So for each x, we're going to sort by x of 1. Then what we could do is we're going to split these into 2 different lists again. So to split these, what we're going to do is we're going to have nums sorted is equal to, nums sorted, comma, mapped sorted is equal to zip combine, and then what we're going to do is, instead of zipping together, we're going to multiply, use the multiply symbol, combined, and this undoes the zip. Then we can return nums sorted. If we run this, Sorry, we want to unzip combine sort. So if we run this, passes our test cases, and if we submit it, passes all solutions. Thank you, and follow for more daily LeetCode solutions.